Hi, it's Carly McAvoy. I'm doing quadratic equation applications today. In the first one, we're talking about a geometry problem where Reason has ordered a kit to build a rectangular dog pen that's supposed to have an area of 84 square feet. When the fencing arrives, he sees that it's in 2-foot pieces. The instructions said that the length should be 8 feet longer than the width. What should the dimensions be? I don't really have to worry about that 2 feet piece. It's just that if we got something that was like 3 by 7 or something, we'd be like, wait, we only have 2-foot pieces. But so what I would do first for this problem is to draw the picture of what I'm dealing with. The instructions say that the length should be 8 feet longer than the width. So if the width is W, then W plus 8 would be the length. I know that the area for a rectangle is length times width. So, and my area is 84. So I'm going to start here and say 84 equals W times W plus 8. If I distribute that, I get 84 equals W squared plus 8W. And if I move the 84 to the other side, so I can factor to solve, or you can use any quadratic solving technique that you prefer, a quadratic formula, complete the square, whatever, that's up to you. But I'm going to use factoring because it's easy to factor this one. I can see that 84 would factor into, I have a bunch of options, 7 times 12 and 2 times 42 and so forth, but I'm going to go with 14 times 6 because 6 and 14 are 8 apart. And I want to have more positives, so that would be positive 14 and 6 negatives. That way my negative times positive gives me a negative. And to solve that problem, I'm going to set both of these equal to 0 and solve. And this one, if I add 6 to both sides, I get 6. And if I subtract 14 from both sides, I get negative 14. And I can't have a length of a side that is negative, so I would not use that solution. So that would make me think that the W is 6. And if I take 6 plus 8, that would give me 14, which tells me that my width is 6 and my length is 14, and this is feet. It's important to include your units. And I can do a quick check to say, does 6 times 14 equal 84? And it does. And is the length 8 feet longer than my width? Yes. So that's how I know that I did that one correctly. So factor and then solve. Sometimes you have to look at your solutions to decide which one makes sense for your problem. In this one, it says the length of Sherry's rectangular living room is 3 feet less than twice the width. If the area of the room is 135 square feet, what are the dimensions of the room? Again, we're talking about a rectangle, and again, they give us a relationship between the width and the length. So we have the width, and I know that the length is 3 feet less than twice the width. So when it's 3 feet less than something, that something has to go first. So it has to be twice the width minus 3. I don't need to put dimensions around all of this because for the area, I'm only interested in the length times the width. My area is 135, and that's going to be W times 2W minus 3, and that's 2W squared minus 3W. I'm going to swing that 135 to the other side by subtracting, so it's going to change signs when it crosses. And now I can factor this. If you're having trouble with factoring, I have videos on showing you how I would factor. I'm not showing you how to factor in this because I want to get through these word problems without making you spend 30 minutes watching this. So I know that 2W squared has to be 2W and W, and then I'm going to look at 135 as 9 times 15. And if I put 9 here and 15 here, notice I'm still kind of waiting on my signs for a second. I want negative 3. So if I had negative 18 and positive 15, that would do it for me. And now I'm going to set each of those equal to 0 to solve. to see if I can solve this problem. If I subtract 15 from both sides, that would be negative 15, and divide by 2, I would get W equals negative 15 divided by 2. It's totally fine to get a fraction or a decimal for an answer, but not a negative length, so I know that I'm not going to use that. If I add 9 to both sides, I get W equals 9. That's not going to be used. If I want to find out what my length is, it's 2 times my width minus 3. So 2 times 9 minus 3 is 18 minus 3, or 15. So my width is 9. We're talking about feet again. And my length is 15. And if I do a quick check to make sure that my length times my width actually does equal 135, and does, and that if I took my width and I doubled it and then subtracted 3, I would get my length. 18 doubled it, 9 doubled is 18, minus 3 is 15. So that's how I can check that to see if I was on the right track there. Okay, the next problem is probably the hardest one that we're going to do. It's just different. So a boss wants to buy her employees a dinner cruise, and she has a budget of $900. The cost is normally $20 per person, but if the company subtracts 10 cents for each person when the total exceeds 30 people, what is the maximum number of employees that can attend the dinner cruise if the boat has a capacity of 100 people? We're limited by the 100 people thing. What I want to talk about is X, and it's very important for me to define what X is. X is going to be the number of people that exceeds 30. Okay, and remember that when we're talking about something where we're going to pay money, the cost is just going to be the price times the quantity. So if I brought 30 people on this cruise, the price would be $20 a person. For 30 people, that would be $600. So that's as simple as it is for cost. But we're going to be talking about a price that gets reduced every time we bring somebody on. So if we have 31 people, we're going to pay $29.90. And if we have 32 people, we're going to pay $29.80, because we keep subtracting 10 cents every time we go over 30 people. So that makes it a lot more confusing, but we are talking about the quantity, or the price times the quantity. And that's going to equal the total cost that this boss is willing to pay, which is $900. Okay, so the price is going to be $20 per person, but we're subtracting 10 cents for every person that comes in over 30. So every time somebody comes on, we subtract another 10 cents. And our quantity is going to be, we're assuming that we're going to get at least 30 people, and then we're going to have X more. So X, we're 30 plus X. We have 30 people plus some number that exceeds 30. Like if we had 35, that'd be 30 plus 5, right? And that equals 900. So now I need to do some things to this to set this up to solve it. And that takes a little bit of just, grind it out with algebra, which can be a place where you make a mistake. So be careful. I'm going to foil this. First is 20 times 30 is 600. Inside is negative 0.1 times 30, which is negative 3x. Outside is 20 times x. And last is negative 0.1 x squared, because I have 0.1 x times x, so negative 0.1 x squared, and that equals 900. It's not a very attractive equation. What I'm going to do, I don't like my lead term, that's my term with the highest power, to be negative. So I'm going to be scooting everything to the other side to make that happen. So what I'm going to do is say I'm going to subtract 600 from both sides. I'm going to add these two things together. That's going to be 17x. I'm going to subtract 17x from both sides. And then I'm going to add 0.1x squared to both sides. This can be, you could do it differently. This is just how it works in my mind. And that looks like this to me. I have 0 equals, I'm going to put this in descending order. So highest power, 0.1x squared to lowest power, minus 17x plus 300. So that's what I have right here. And I still don't like this because I want this just to be 1 so I can factor this easier. That's pretty easy. If I multiply this by 10 cents times 10 would be 1. So what I'm going to do is multiply everything in this equation by 10. And that 0 times 10 is still 0. And then that would give me x squared minus 170x plus 3,000. And now I'm going to factor. And when I factor that, I'm going to get x, and it turns out to be 20 times 150, 20 times 150, and that is, I want negative and negative because I have two negatives. 20 and 150 add up to 170 in that. So I have x minus 20 equals 0 and x minus 150 equals 0, which tells me that x is 20 or x is 150. So 20 makes sense, but we have a capacity of 100 on this boat, so we can't actually use that. So it makes sense that we can bring in 20 extra people. But the question is, what's the maximum employees that can attend? X is the number of people that exceeds 30. So we can actually have 30 people plus 20 more, or 50 people